Hello, I'm going to try to do this review here, and I think I got all of my technical issues worked out. So I know if you had the other video, you already had this once, at least part of it, but let me work this one. I'll just work the whole review, and that's what you can use. So in this case, it's asking you to find 3 ordered pair solutions by completing the table. So yes, I realize some of you know how to graph this. You know, you say the y-intercept. Isn't this technically my y-intercept? And then the other one here is my slope. So I do realize you could graph it like this. Here it crosses at y-axis at -2, and then from there you go slope 1, 2, 3 over 1, or up 1, 2, 3 over 1. However, it's asking you to complete the table, so you have no choice but to complete the table. So y equals -3 times 0 minus 2, y equals -2. When x is 0, y equals -2. So we already had that point by using slope-intercept form. I'm going to switch around on colors a lot. I have some nice color options in here. When x is 1, that one, when x is 1, y is -3 times 1 minus 2. Y equals -3 minus 2. Y equals -5. So 1, -5, already a point there as well. You see how it doesn't matter which way you use it, but I'm asking you to complete the table, so you'd have to do it that way. And then the last one, so it depends on the problem and if you're doing it in my math lab. And excuse me, I've been here since, for 6.5 hours or 7 hours already. So my eyes are already a little bit blurry. So it could happen that I'll make a mistake, actually. But if I do, I'll catch it. -1, 1. See, those all points were already on the line. And then you graph it. And, if you use my math lab, whoa, it's going to be a lot straighter than this. Okay, but I'm making this video for everyone, really. So even on-ground students can do this. The test looks similar. It has the same type of questions, pretty much. All right, let's get out of this one. I don't know how to clear this. Can I just clear this whole thing? I didn't check that out. Maybe I can clear. I have to erase it all. Oh, okay. Let's see if when I use this tool, if it'll just disappear. So it'll just disappear. We're okay. To use my mouse a little bit at times. This is very touchy. Okay. If you have to find the intercepts, then you should say XY chart always works. And you could just let X be 0, and then you get the first term disappears. So in class, I tell my students, just hide this thing. Like you could take this thing and hide the whole thing because it disappears. But if you need the calculation, some students do. I'm not against it. So this turns into 0, so you're left with -9y equals 18, which is why I was saying just cover up the x term with your finger. So when x is 0, y is -2. And then the other one is, so 0, -2 is right here. And then the other one is, when y is 0, you could say -3x minus y, 9 times 0 equals 18. -3x equals 18. So x equals -6. So that is your other point. And then you connect those two. So it's asking you where the intercepts are. So I want to specifically know, where does my line cross the x-axis and y-axis? I don't know if I have it, if this shows where I'm holding this mouse. I hope it does. But can you see the line crosses the x-axis at -6, 0? Or you can just say -6 in this case, because it didn't state you need to show the show it in ordered pair form. And then where does it cross my y-axis at -2, or in ordered pair form, 0, -2. Okay, next. Find the slope of the line. So at the beginning of your test, it's showing you, it's given you some formulas, and you should use the slope formula in this case. So we're going to label this x1, y1, x2, y2, m equals y2 minus y1. This is a little dangerous, so you have to be careful. You know, this here is my minus from the formula. And this is where a lot of students make mistakes. They just grab a -4, and they don't say it's a minus a -4. And then the denominator, x2 minus, from the formula, x1 is -9. So you get a -6 plus a 4 over 3 plus a 9 equals -2 over 12 equals -1/6. So your slope is -1/6. Okay? Then I have a few people that are all gung-ho, and they actually end up writing an equation of the line with those. Nobody's asking you to do that, so please don't do more than you need to. You're just going to find the slope. Okay, find the indicated values. Okay, so in class, I tell students, this is function notation, so it just looks a little different, but f of x is really the same thing as you saying y. So x doesn't equal y, f of x equals y. So what this means is, in this case, for example, h of 0 equals, this part here is really y. So what do? You're plugging in a 0 wherever you see an x, so you have 0 squared minus 3 times 0 minus 5 is -5, right? So what does this mean? Then I ask people, hey, write the corresponding ordered pairs, and they struggle with this. They don't know what to do. And I want you to remember this. When is y -5? When is y -5? When you said x is 0, okay? So when x is 0, y is -5. And then the other one is h of -1 equals -1 squared minus 3 times -1 minus 5 is -1 squared is 1. And just a bit of basic math, -1 squared does not equal -1 squared. This exponent here touches that parentheses, so it's a -1 times a -1 technically. This exponent here only touches, on the left, this exponent only touches the 1, so it's only the 1 that's multiplied by itself. So be careful that you use parentheses, and that way you will not mess this up. 1 plus 3 is 4, then you get a -1. When this is what? Y equals -1, when x equals -1. So this is just a coincidence that they're both -1. Essentially, it's x is what you put into the function, and y is what comes out of the function. So let's see. Determine if they're parallel, perpendicular, or neither. How do you know if something's perpendicular or parallel or neither? If m2 equals m1, they're parallel. You know this already because you did this in previous sections. And if m2 is the opposite reciprocal of m1, then it's perpendicular. And I'm going to say here opposite reciprocal. How do you know what m is? Well, how about you isolate the y, right? That's all we have to do here. So I'm going to do, well, okay, let's do line 1 in green. Line 1, isolate the y. So if you don't know how to isolate a y at this point, is what I tell students in class, you have to get help. It's urgent, okay? You have to bring over the 3x, then you isolate the y, so you're dividing by -2. -3 divided by -2 is 3/2. And this is technically, who cares what that 10 divided by -2 is, really? We don't care where the intercept is. What did we want? We wanted the slope. And please don't tell me that the slope is a 3/2 x. The slope is a 3/2. It's the coefficient of the x term. And then we say, well, what is the other one? So line 2 in purple. 2x plus 3y equals -9. 3y equals -2x minus 9. Y is -2/3 x minus, and I don't really care that that's a 3 either. I care about this coefficient of the x term. So m2 is, whoops, why is it erasing this? m2 equals -2/3. Oh, it's not liking it on that page, I see. Okay, I'll do it over here. Since I'm working within the paint options within the Word document, that's why. If I was using the other annotation options, I could go over the page. Okay, so what does this tell me? This one here and this one here are opposite reciprocals of one another, and that means my final answer on which one it is perpendicular, right? That's my final answer. So all of those items are your final answer. There's 6 points attached. All of those items are your final answer. Okay, find an equation of the line with a given slope that passes through the given point. So when I'm teaching this in class, I always say, focus on what is given. You're given a point and a slope. So use point, slope, form. My handwriting is not the greatest. Deal with it. It's not going to get any better. It's just the way it is. Okay. And I would be more fun if it wasn't late afternoon and I'm tired. Okay, given a point and a slope, so use point slope form, which is this thing. And you're given the formulas, but you're not told what name they have. So you need to recognize this as the point slope form. What do? You leave the y alone, minus, you plug in the y, here's x1, y1. You plug those in. Then you have a slope of 1/4 times x minus x1. Then you have a y minus 6 equals 1/4 x plus 5, because I clean up the inside first, right? And then you're going to distribute. I'm showing you one step at a time as if you were a student in class. Now, you need to be able to handle these fractions. 1/4 plus 5, 1/4 times 5 is 5/4, right? So I might show here the basics, you know, go across. We don't usually have time to go into those great details. And then you have to turn around and look here. Now you're going to add 6 down here. Whatever you do here, you do here. And then I have folks that really struggle with this. And I'm going to work it up at the top. 5/4 plus 6/1 is 5/4 plus what over 4? Common denominator needs to happen, right? 1 times 4 is 4. 6 times 4 is 24. So you're going to get a 29/4. So let me use my other pen again. I'm going to run out of room because I write big and then, yeah, it gets tight. Y equals 1/4 x plus 29/4, because we did this up there. Now, it says write your answer in standard form, which is ax plus by equals c. And it says in standard form, you can't have a negative leader and you can't have a fraction. So let's look at this thing here. I hope you can see my pointer. I don't know if you can, but let's look at this. This is what form? This is the slope-intercept form. And if it just asked you to write an equation of a line and it didn't specify, you could just use this as your final answer and it would be fine. But it did say standard form. So we need to move the x's over. So you're going to get negative 1/4 x plus y equals 29/4, right? Because that's the basic manipulation of an equation here. You're subtracting 1/4 x from both sides. Then you have a negative leader, because that coefficient on the x term is negative, and you have a fraction. How do you make those disappear? So what can I do? Some of you will just divide everything by -1, but some of you will go ahead and multiply this thing by -4, because when you do, the 4's cancel and the negatives cancel. Whatever you do to one term, you have to do to all of them, because that is rules of equations. So you're going to get -4 times -1/4. 1/4 times 4 is 1, and negative times negative is positive. So you just get an x minus 4y equals, and nobody cares what 29 times 4 is. You're simply going to cancel the 4's and say 29 times -1 is -29. And that is your final answer in standard form. Okay. Find the domain and the range. So domain is all the x's and range is all the y's. So this is really basic. Super easy, right? So you just have a list. 10, -10, -3, 11. You don't even have to put them in order. The computer didn't make you put it in order from least to greatest. And then the range of all the y's, 3, 0, -3, -10, full points. This is a gift. If you get this on the test, you'd be happy. The online test, yes, it looks slightly different, but I'm telling you, actually, there's like 1 or 2 problems in the online one that look a little different. That's it. And you still have all the skills from this one that you can use to solve those problems. Okay. Is this relation a function? So you can do this different ways, but the one thing that students really like is real quick to memorize. If the x's don't repeat, it's a function. The other thing is you can look at this as if you were to plot those points, vertical line tests. So -4, 9, -2, -1, and I'm just sketching. 3, -8, 6, 9. Do you see how if you put vertical lines through, they would cross at the most once. They would never cross more than once. So that makes it a function. Now, you do see these are repeating. Oh, I didn't even put them in the right place, -4, 9. Okay, so let's say you had this one and this one. Doesn't matter if they repeat. The y's can repeat. The x's cannot repeat. Okay, so let's keep moving. I'm trying to get this done fast. Where can I tell how long this recording is already? I can't. Okay, we'll just go with this. Solve by graphing. Okay, first I need to clean up this mess. If you like y equals mx plus b, you could just graph using this. And then people are like, but it fell off the graph. Yes, it fell off the graph. 5, 6, 7, 8, 9, 10, 11. That can happen sometimes. So it crosses at that point, and then from there you have a slope, -3. 1, 2, 3 over 1. 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 So there is your graph of the first line, and you have to excuse my sketch. It's going to get messy. If you don't like this, you could use the original, and you could do an XY chart. XY chart always works, but when X is 0, Y is still 11. So that doesn't really help you find a better point. But, you know, if you let Y be 0, you're going to get 11/3, which is not everybody's favorite. However, what if you just let X be a 1, for example? You know, think about that. If you let X be a 1, then you would get 3 plus Y is 11. Then you isolate the Y and you get Y is 11 minus 3 is 8. So 1/8 is mathematically fairly easy. And there you have 2 points. 1/8, is that on my graph? 1/8, yes it is. And then if X is 2, 3 times 2 plus Y is 11. 6 plus Y is 11. Y is 11 minus 6 is 5. So, for example. So that's also on my graph. So then we graph the other one, the pink one. So I'm going to just use Y equals mx plus b because it's already in that form, right? It crosses my y-axis at -3. And from there I go slope up 4 over 1 over 1. And there's my line. Whoa. Okay, your line will be straight. Mine isn't. I know they have a line tool, but I don't like using those. So your line would be straight. Just don't get hung up on my ugly line. Okay, so where do they meet? That's the solution to the system. Solution to the system, 2, 5. They meet at 2, 5. And you don't have to do the solution deal since it already says solution to the system. Okay. So let's keep going. We're trying to get work done. Solve the system by the substitution method. So you can solve any of these systems by any of the methods. So you could graph them all, or you can substitute them all, or use addition on all of them. But it's, you know, it's asking you to use specific methods, so you really should. And in class, you have to, because I'm looking at your work. Okay. So you have a decision to make. You need to isolate. When you're using substitution, one of the rules was you need to isolate one of the variables. The question is, which one do you want to isolate? And this is where you have 4 choices, and you can make 2 really bad ones. You can make 1 okay one, and you can make 1 really good decision because it's the easiest. So let me look at the ugly ones. Do not write this down. Okay, don't write this down. But if you said, hey, I'm going to isolate that, if you take this line, and I'm just playing with this now, so don't do what I'm doing, please. Okay, my on-ground students are always, when I say don't write this down, they write this down. So don't write this down. I'm trying to show you something so you fully understand what's going on. Okay, if you isolate that y, and then you have a -7/6x plus 73/6. Whoops, it's falling off my graph. Plus 73/6. Do you see how this is hideous? So avoid that. You can avoid that ugly fraction. If you isolate this guy, you have the same problem. You're going to bring the 6y over and divide by 7. Still really ugly. So let me get my big eraser and get rid of this mess. The other equation is the one you want to work with. And then I have a bunch of students, even today, after I talked about it last week, who chose to isolate this y. I'm not against it, but think about it. If you want to isolate this y, you're going to bring 2x over, and then you have to turn around and divide by 4. That gives you a fraction of 2/4, which is a half. And if you want to avoid altogether fractions, you can. Oops, hang on. I'm still learning how to use this stuff really well. Okay, so the best one to isolate is this x here, because look, you're going to move 4y over, And you're going to turn around and divide by -2 everything, every term, right? Both sides completely, everything is divided. So x equals 2y minus 1. Do you see how that is the easiest thing you can do? It's nice and clean. It doesn't have any fractions. Now, if you isolate that one, then you're going to take that x and you plug it back into there, into the other equation. So we have -7 times x happens to be 2y minus 1 minus 6y equals -73. Then we distribute. -14y plus 7 minus 6y. Be careful with the distributing. Anytime with this video, right, you can just hit pause and say, oh, wow, what happened? How did she get that? You know, you distribute. Negative times negative is positive. Okay, now we combine like terms. They're on the same side. So I borrow $14. I borrow $6. I owe $20. I don't do the opposite to it if I'm combining. And then now you're going to subtract 7. And if you do a basic math mistake here, you will probably catch it, because guess what? When you get a really ugly fraction, you might want to consider. I'm not saying it couldn't be a fraction, but most of them are not really ugly fractions. So I get a y is 4, and then I plug this into either. Which one's the easier one? Well, I'm going to grab that one. That 4 goes right there. So subtract 16. And again, if you need to pause here, I'm going a little bit faster because you can pause. And I've been here a long time and I'm ready to go. Okay, so x is 7, y is 4, and that's the solution to the system using substitution method. If I asked you to use addition method on this one, you would have to create some x's or y's that will cancel when you add them. So we're going to do that on the next one. At least I'm getting my pen to work. Come on. This is getting a little slow. Okay. Now it says by the addition method, and this is also called the elimination method, which I like that term. I like those terms together because it tells me when I'm adding them, one of them eliminates. So it disappears. That's the plan. So I had a bunch of students. I'm not against it. I'm telling you, it's different is not wrong in math, okay? So I have a bunch of students who said, hey, work on the y's, you know, make the y's disappear. I'm going to work on the left side the way I would solve this thing. So don't do what I'm doing over here on the right. I'm just saying, if you want the y's to disappear, you would have said, hey, I'm going to multiply this one by 3 maybe, right? So then you would get, and whatever you do to one, you do to all, but you could multiply this by 3, so you would get the 6y. And then you would have to multiply this one by -2, so you get a -6y. And I'm not filling in this part of the equations. But you see how that's the goal, that when you then add them, this disappears and you just have some excess, whatever that is, equals some number. And there's nothing wrong with it. It's just more work than I want to do. So you look at this and you make decisions. What's easier than that even? Or what's quicker? You can say, hey, what if, I already have a 6x there. Could I make the other one into a -6x really quickly? And then I don't have to work as hard, you see? But you eliminating the y's, you'll still get exactly the same result. So don't think it's not okay. So I would get a -6x minus 12y equals -60,108. And then I have a 6x plus 3y equals 27. Then you add them together, and guess what? The x's in this case eliminate. -12y plus 3y is -9y. -108 plus 27 is -81. Y equals 9. Cake. You see, this was not difficult. And then you plug that 9 in, either one of the others. Well, to me, the top one looks smaller numbers, so I'm going to use it because it makes my life easier. So I'm going to let y be the 9. And then I'm going to solve. (18 minus 18). There's nothing wrong with having a 0 as a number, right? And so this is telling me that x is 0 and y is 9, and that's the solution to the system. What does this really mean? It means that if you graph these two lines, they would meet at 0, 9. Both of those lines go through 0, 9. The other thing you can do to check, if you wanted to check your work, I like checking my work, but to check, you could just use a different method. So you can either graph them both or just sketch it, or the thing that's really fast and easy in this case is look at the top one. If you isolate that, it won't let me write on here. Negative 2y plus 18, so x is negative 2y plus 18. And you could plug that into that 6 times x plus 3y equals 27. So if you plug this mess into here, you would get, you would solve, and then you would see if you get the same x's and y's. So, that's one way to check. The other way to check also is, so you can either use different methods or you plug that point, that point that you found into both of the originals, and it has to create a true statement. So that's another way. If I were in a testing situation, I always used to do this. If I was done with my test, I wouldn't do it. This kind of checking I would not do in the middle of a test, because what if I run out of time? But I would definitely at the end say, hey, you know what? I have time. I'm not second guessing myself and making changes to my original. I'm just going to see if those points make a true statement in the original. So you can check your work. Just don't get so hung up on it that you can't work. Okay, solve the compound inequality. First things first. And I will explain the difference between intersections and unions. This is really important here. So x is less than negative 1. So let's say we have a 0 here and a negative 1 here. X is less than negative 1. Less than means parentheses, and then we would have a graph that looks maybe like this. The other one is so I would subtract 3 from both sides, right? Negative 20. X is, now if you're dividing by negative, this is key that we need to flip that symbol. Okay, that's one of the main mistakes that happens. Divide by negative, you flip the symbol. So it's x is less than 5. So the graph says 1, 2, 3, 4, 5, less than 5. And this is just an intermediate step of mine. And then we talk about the keyword. And so before I say what's my final answer, what is my final answer? I look at and. If it says and, hang on, let me grab a different color. Orange is one of my favorites, but that's not always as easy to see. Let's do this. So if it's and, that means it's the intersection. And that means intersection means double shading. Those are the 3 things you need to put together. Intersection means double shading. Where do they overlap? Intersection, where do they meet? Where do they overlap? So a lot of people here say, oh, it's from negative infinity to 5. And I'm like, oh, I forgot to put the 5 in there. Hang on. I got to fix that. Here's my 5. But really, where is the double shading? Double shading is here, isn't it? So my final answer is really that. And then in class, I tell my students, use the graph to do your interval notation. So you see a parentheses, it starts at negative 1. Where does it go? Negative infinity is over here, close parentheses, and then you get full points, okay? Now, I do like to talk about what if this said or, you know, and this isn't this problem, but what if the problem said or? And this is, I'll do this again on the next one just to clarify. But if it said or, it means union. And union is any shading. So this is not the answer to this problem. But if it said or, you would say, hey, any shading, anything that's shaded, I see that. It starts at 5 and it goes to negative infinity. So hopefully that helps a little bit. And then we'll do the next one. Thanks for hanging in there. I hope this is recording. I've done this before where I thought I was recording and realized then later it hadn't worked. That could happen to me. Yeah. Okay, so let's look at this one. I showed this in class that you can move those X's to the right, but I'm going to heavily advise you. I showed them this and I'm not going to do it again now because of time, but I would strongly advise you to keep the X's on the left on the inequalities. So I'm going to subtract 2x, and then you're like, well, what do I do? Everything disappeared from the right side. And I'm like, then let it be a 0 because it's okay for that to be a 0. And then you say, well, now I need to isolate the x, add 4 to both sides. Now I need to isolate the x, divide by 4. If you move it to the other side, it's okay, but then you have to divide by negative, which flips your symbol. Then you have to move your x's to the left. So you're still going to get exactly the same thing, but you might be confused. So here's a 0, here's a 1. X is less than 1. So that would look kind of like this, roughly. Okay, and then we have the other one. So negative 3x less than or equal to negative 9, divide by negative 3, divide by negative 3. And if you're dividing by negative, what do? Oh, wait, you flip your symbol. So x is greater than 3. 3. Greater than or equal. So it gets the bracket, right? Because greater than or equal means bracket. And then you have to say, now what is my final answer? And your final answer does depend on this or. Really does. And when it says or, you need to say or means union. Or means union. Union is anything shaded. So what do you see? And I'm going to do it. I'm going to try. I can't fit it below there. I always say drop down below your graph, and I didn't drag it far. I wonder if I can, let me see if I can move it. There we go. That'll work. So we're going to say I see a parentheses, I see a 1. Where does it go? To negative infinity. And then I see a 3. It starts with a bracket. Where does it go? To positive infinity. And then you say, well, I have a gap in the middle, so you use a union. And remember, always use parentheses next to infinities. Okay, so whether it's on the left or on the right, doesn't matter, but you're going to use parentheses next to your infinity symbols. You cannot use brackets. Okay, so then we do the same thing with we did earlier with the blue here. So my final answer is already there. But what if this said and is the intersection? You have to memorize that. So I usually say union, OU goes together, or is union, OU, and then the other one is the AI. AI goes together, intersection. Okay. And means double shading. Where do you see double shading in here? Nowhere, you see? And intersection means where do they meet? So if it said and, you would say no solution. So it depends on that one little word. The graph is the same at first. If in this case here, the final answer graph would be just a blank. So Oh my goodness, I'm going to use my mouse, maybe faster. Solve the absolute value. See, we're almost done. So we're getting there. It's going pretty fast. I'm explaining everything I try, so that takes longer. Absolute value is the distance from 0 on the number line. This is important and can never be can never be negative. I have something is bothering me. I don't want it to restart now because my computer is wanting to restart now, and I do not want that to happen. Okay, can never be negative, meaning you can't say the absolute value of something is a negative number. That is completely illegal and impossible, okay? But you see how the inside can be. Okay, so the absolute value of -5 is 5. That's the distance from 0 to the -5. That is okay to say. The absolute value of -5 is 5. The inside can be negative. The outside can never be negative. This, regardless of what that on the left is always going to be positive, okay? So what I want you to get out of this, there are two things that make that statement true. The inside can be either a -8, because the absolute value of -8 is 8. The distance you go from -8, from 0 to -8, that distance is 8. You see, you cover 8 steps. And the absolute value of 8 is also 8. And I usually show this with a bit of a, oops. Oh, now I have a small eraser. Hang on a second. I already explained it. But a little bit of a visual, you know, if you have a number line from 0 to 8, you walk 8 steps. From 0 to -8, you walk 8 steps. That thing up here, the distance you go is still positive, you see? So the inside can be -8, or the inside can be +8. So then you solve both of those. So 8m equals -14, m equals -14/8. This is basic math. If you're stuck here, you need to follow along, pause it, follow along, figure out how to get. In pre-algebra, we show the operation, you know, like -6 divide by 8 divide by 8. We show that operation in pre-algebra a lot. In intermediate algebra, I don't show that anymore. Okay, I assume you can do it. So 8m equals 2 because I subtracted 6, you see? But yeah, we have lots of people who could do really well at algebra, but they're hung up on that basic math. Fix it. You need to see someone, come see me, do something, set up an office hour so we can fix it. Okay, divide by 8. See, now I'm saying fix it, and then I show the work. So m equals 1/4. What does this mean? My final answer is going to be -7/4 and 1/4. Now, folks, okay, you can't use parentheses here because that would make it an interval, either an interval or an ordered pair. What this here means, this means these two specific values for m will cause a true statement in the original. So I'm going to check it. So let's check it in green. Let me plug in the -7/4. I might not do them both. And you see how this looks a little ugly, and to someone who doesn't like fractions, it can be very intimidating. But folks, this is just 8/1. And guess what? A -8/1 and the 7 and the 4, the 8 and the 4 cancels into a 2, right? Or you can say 8 times 7 is so-and-so divided by 4. But for me, it's easier to just do -14 plus 6. What I'm trying to show is this 8 and that 4 cancel into a 2, okay? So however you do your fractions, make it work. Use a calculator, do something that works for you. You're allowed a calculator, take advantage. And then I'm asking, is this true? The absolute value of -8 is the distance I go from 0 to -8. The absolute value of -8 is 8, and 8 equals 8, true. And then the other one is actually more straightforward, so I'm not going to check them. You know, the 1/4, it'll check just as well. Oops, second. So we're getting there, we're getting there. This is the last one, I believe. Yeah. So. Graph the inequality. In the notes, I would have said, act like it's a regular inequality or any regular equation first. So I would have graphed it like this. So find, oops, that doesn't like it. Find some points, okay, on the line. So what do you do with this? Well, you can say y equals -4x minus 6. So here's your y-intercept. Here's your slope. So we can do it that way. Cross is at -6, slope is -4. 1, 2, 3, 4, 1. Or up 1, 2, 3, 4 to the left 1, regardless it's a negative slope. Now I almost wish this one were an inequality without an equal sign, because then you have to think right here, this before I connect those, I need to look at that and say, is it solid or is it dotted or dashed? This is a solid line. So that's why I don't like it that much. Oh, and remember, I'm not going to graph a straight line because I can't, but it's close. Okay, and then you don't stop here. And also, if you do an XY chart, you know, when X is 0, Y is -6, and then you want to let X be a 1 or something, and you're going to get a decent number out of it. We've already done this on the first one. I'm not doing it again. Now, what else do we need? Since it's an inequality, we have to shade. So shade aside. There are numerous XYs that make that original statement true. How do you shade? Use a test point. And we did this in the discussion, or we did this in class. And I always, if I can, I use 0, 0 because it's mathematically easy. I don't want to use 0, 0 if my line goes through that point, because then that tells me nothing. That just tells me it's a true statement. It doesn't tell me which side to shade on. But since my line doesn't go through 0, 0, I can go ahead and use it. And it makes it mathematically super easy. I want to know, is this true? 0 less than or equal to -6. Is that true? 0 is greater than -6, so this is false. What does that mean? Well, where that 0, 0 lies makes a false statement, so I don't want to shade over here. So where do I shade? I shade over there. And then I have full points. So I hope this helps a little bit. I hope that you take advantage. It's similar to the online test if you're an online student, and it is very similar to the on-ground test if you're an on-ground student. Call me if you need help, email, text. Just don't ignore your problems if you have them, so we can fix it. Thank you.